Okay, so inductive effect is basically depends on the distance, and inductive effect is inversely proportional to distance. As the distance increases, inductive effect will decrease, right? And I told you it is a displacement of electron. So basically a group can donate the electron density, a group can withdraw the electron density. Both the things can happen, right? So basically there are two type of effect arises, which is plus I and minus I. Plus I and minus I. Plus I will be the effect which is electron donating group, and minus I is the effect which is electron withdrawing group, right? Plus I is the group which will share the electron density, which will donate its electron density, and minus I is the case which will withdraw the electron density, right? Okay, then let us see what what will be the groups which will be coming in plus I. So basically I am giving you very simple example. Hydrocarbon, like to remember, hydrocarbon, or basically we can say as sp3 hybridized carbon. For example, CH3, C2H5, CH3, CH3H, CH3, CH3, CH3. These all groups are better. What are these groups? These are hydrocarbons only, right? This is methyl, this is ethyl, this is isopropyl, this is tertiary. So all these groups are basically having plus I effect. They are having electron donating effect. Next is what? Next is negatively charged atom. Negatively charged atom or ion. For example, we can say as O negative. So O negative is a negatively charged oxygen atom, and NH negative we can say as NCH2 negative. So basically what these negative charge will be doing. So any negative charge cannot withdraw the electron, right? Because it is already having high electron density. So it will be sharing the electron density only. It will be sharing the electron density. It will be sharing the electron density. It will be donating the electron density, right? So any negative charge will does just wants to reduce its negative charge, right? Any charge just want to reduce the amount of the charge. So how the negative charge amount will be reduced? When it shares the electron density. When it shares the electron density, right? When it donates the electron density. So any group basically shifting the electron or pushing the electron away from it, then that group is called plus I group, right? So this is the plus I group we are having. Okay, then we can see the minus I groups. Understood from up to here?
Yes, sir.
Minus I groups. Minus I group are the one which are withdrawing the electron density. Electron withdrawing group. We call them electron withdrawing group. Okay. So now what will happen? First, we can say what will be the electron withdrawing group. We can say positively charged ion. Positively charged ions. For example, NH3 plus, NF3 plus, OH2 plus, OF2 plus. Beta, you can see these are positively charged ion. So they will be withdrawing the electron density, na yaar? Because they are positive. So they will be attracting the electron through the bond. They will be like in the bond, there will be electrons. So they will be withdrawing the electron, attracting the electrons towards itself, right? So we can say positively charged ions will be having minus I effect. Second thing, atoms which are more electronegative than sp3 carbon, right? sp3 carbon, which is more electronegative? Nitrogen is more electronegative, fluorine is more electronegative, halogens, all the halogens are having minus I actually, right? All the halogens are having minus I effect only. Chlorine, bromine, iodine. OH we can say, OCS3 we can say, right? OCS3 also we can say. And then NH2, fluorine, OH, OCS3. So these all groups are minus I group. Even sp2 carbon. sp2 carbon. This is sp2 hybridized. Why it is sp2 hybridized? Because this carbon has made 3 sigma bonds. That is why it is sp2 hybridized carbon. So when it is sp2 hybridized carbon, it will be having minus I effect only, right? It will be having minus I effect, because if you see the electronegativity, then sp, then sp2, then sp3. So which is the highest electronegative element? Sp. So we can say, if you see the sp carbon also like that, then that will also be having minus I effect. So atom which are more electronegative than sp3, they will be having the minus I effect, right? And which are the more electronegative atom? Nitrogen, oxygen, halogens, and sp2 carbon and sp carbon also. And how to find this hybridization? Just by counting the number of sigma bonds. You can see there are 3 sigma bond carbon has made, so sp2. And here 2 sigma bond carbon has made, so sp only. And if carbon has made 4 bonds, then sp3.
So, sir,
Okay.
can you explain again?
Yes. So this carbon has made how many bonds, Varun?
4.
4. And how many bonds are sigma?
2.
3. 3. Like this, among these 2 bonds, 1 bond is pi and 1 bond is sigma.
Oh, okay, sir.
Okay. So 3 sigma bonds, na? That means 3 orbitals should be required to mixing. That means sp2. 1 s orbital, 2 p orbital. Hybridization is coming as sp2. And here how many sigma bonds? Only 2 sigma bond. These 2 are pi. Among between 2 atoms, there is only 1 sigma bond. So 1 sigma and 1 sigma. 2 sigma bond, that means the hybridization will be sp. If you see this, how many sigma bond carbon has made? 1, 2, 3, 4. So 4 bond, that means the hybridization will be sp3,
Oh, okay, sir.
right? The number of sigma bond whatever is there, that same number of orbital will be used for mixing. Okay, fine.
Yes, sir.
Okay, then next we can say as atoms having partial positive charge or polar pi bonds. For example, C double bond O. Beta, in C double bond O, if they ask you, like we can write the aldehyde. Suppose we write C double bond OH, and if they ask you what is the effect of this, carbon? So basically, this is having a partial positive charge. How this charge is coming? This is coming because of the oxygen. Oxygen is more electronegative. That is why the carbon is having that partial positive charge. So this carbon will withdraw the electron density. And if it withdraw the electron density, that means we can say it has the minus I effect, right? I told you, no, the positive charge is there, then it
Yes,
will
sir.
withdraw only, so it will be having minus I effect. So another thing we can say is cyanide, C triple bond N. Here also carbon is attached with more electronegative, that means it is having partial positive charge, so it will be again having minus I effect. C double bond O, CS3. Like any group which is C double bond O, any group which is C double bond O, that will be having minus I effect only, because there will be carbon and partial positively charged carbon. That means it will be minus I only. C double bond O, OH, that will also be partial positive charge, and partial positive charge, that means minus I effect. Got it?
Okay, sir.
So I told you about this. You can remember this by polar pi bond also. What do you mean by polar pi bond? There is no En difference. Sorry, polar means when there is En difference, electronegativity difference is there, and pi bonds are there. So that group will also be having minus I. So you can remember by this also. Polar pi bond, polar pi bond, polar pi bond, polar pi bond. That means we can say these groups will be having minus I effect. Got it?
Okay, sir.
Anirudh?
So 1 second. Sir, delta minus will accept the electron, sir.
Delta minus will come when atom withdraw the electrons. So this nitrogen will withdraw the electron. That is why delta negative will be coming here.
Sir, when will you know that if the given compound is more negative than CH minus CH3 carbon, sir?
Beta, just by the electronegativity are periodic table, carbon, nitrogen, oxygen, fluorine. You see
Okay,
left
sir.
to right, electronegativity increases in the periodic table.
Okay, sir.
Have you taken those classes, periodic table?
Yes, sir.
And I told there, na, in the electronegativity left to right, there is a regular increase in electronegativity.
Yes, sir.
And down the group, regular decrease.
Okay, sir.
So I am giving a question now. X minus Y, you have to tell. Okay. CS3, C2H5, OCS3. Okay. Now will you be telling?
Yes, sir.
Okay. So like suppose CS3. CS3 is a hydrocarbon. And this hydrocarbon, I told you sp3. When the carbon is sp3, then it is having plus I effect. Right?
Okay, sir.
Like that we have to do. Like I told you this category, you can see again. You can see again plus I and minus I category.
Okay, sir.
Now you try.
So second is also sp3.
Huh. C2H5 is what? This is CH2CS3. CH2CS3. And that group is also plus I effect. NO2. What about NO2?
So minus I.
Yes.
Minus I. Because if you see the structure, na, then that looks like that. If you see like that also, like nitrogen is having partial positive charge because of polar pi bond. And this is nitrogen, yeah. Nitrogen is more electronegative. You don't even need to be confused about it. Because nitrogen is there, which is more electronegative. No options. It will be always be minus I. Then CN. CN is a triple bonded carbon. And triple bonded carbon means again polar pi bond. And polar pi bond means again minus I effect. COCl. How does COCl look like? COCl will look like this. And this will be having minus I effect again. This is again CO minus I. pH. pH means what? Benzene. And benzene, pH means phenyl. And phenyl means benzene. So benzene may, in the benzene, this carbon is sp2 because it has made 3 sigma bond only. And 3 sigma bond means minus I. And this is sp carbon again, minus I. sp2 carbon, minus I. Fluorine, minus I. Negative charged. Negative charge will always be plus I. This is oxygen, this is minus I. Okay. So what is the value of X we are having? X we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the value of Y we are having? 1, 2. 1, 2, 3. 3. So what is the X minus Y? We are having at 6. So how much you got?
Sir, I was confused for pH, sir.
pH. And for other
Other
cases?
I got correct.
Okay. Anirudh?
So I didn't get the last one. I got the remaining.
Okay, but OCS3 is simple, na? Oxygen is there only. And oxygen is more electronegative than carbon. That is why minus.
Yes.
Okay. So this is about the recognition of the group, right? Plus I and minus I. And now we will see its application. Actually, we can tell the stability of intermediates. Stability of intermediates. Stability of intermediate means what are the intermediate actually? You can have carbocation, you can have carbanion, you can have carbon free radical. Okay. Carbocation means that is a electron deficient. Because in carbocation, carbon will be having only 3 bond. Carbon and carbon will be having 3 bond, but it will be electron rich. This is carbon free radical. It is also electron deficient. Why it is electron deficient? Because it is a 7 electron species. How it is 7 electron species? Because you can see 1 electron, 2 electron in this bond, 4, 6 and 7. And here 2, 4, 6. Here 2, 4, 6 and this is 2 electron pair. So 8 electron species. So 8 electron species means octet is complete, and octet is complete, that means it is stable. And it is a 6 electron species. Okay. So in this way we can tell that its octet is incomplete. In the case of carbocation, octet is incomplete. Incomplete. In the case of carbanion, octet is complete. In the case of carbon radical, octet is again incomplete. Okay.
How
So
many electrons are there in this last one? Radical.
In the radical, there is 1 electron, this one, and 2 electron in this bond, 2 electron in this bond, 2 electron in this bond. So total 7 electrons are there.
Okay, sir.
Okay. Yes. So now we can see the stability of intermediate. You tell me, beta, when the carbocation is there, then it will be stabilized by electron donating group or electron withdrawing group?
Donating.
Electron donating group, right? Because it is electron deficient, it needs electron. So when electron donating group is there, it will become stabilized. What about carbon ion?
Electron accepting.
Yes, it will be stabilized by electron withdrawing group. And same here, stabilized by electron donating group. Okay. So now we will see how does it become stable. Okay. So suppose we are having some cases, carbocation, carbocation, carbocation. This is CS3, this is fluorine, this is chlorine. And you have to compare the stability. Okay. How we will be comparing the stability? One question I am telling you. You have to see the plus I effect beta. So in this case, there is a CS3. Like you have to see the things which are not common. This is the thing which is different in them, right? So CS3 will be having plus I, and due to plus I, carbocation will get stable. Fluorine has minus I, chlorine has minus I. Now, so we can say A, B, C. A is most stable one. If we talk about B and C, so in both B and C there is a minus I group, and minus I group will withdraw the electron. But which will withdraw more? Fluorine will withdraw more, right? Because En of fluorine is more. Like En, electronegativity decreases down the group. When we go down the group, it decreases. So fluorine is having more electronegativity. Fluorine has more withdrawing power. So A, B, C. This is the order. So did you understand this one here?
Yes, sir.
So
Yes.
basically, to compare this, we need to compare the plus I effect. Like suppose two groups, suppose carbocation is there, and in one case plus I group is there, in one case minus I group is there. So among these you can differentiate. Like the case where plus I group is there, carbocation will get stabilized, and the case in which minus I group is there, carbocation will get unstabilized. But the point is, what about when you are having two plus I groups? When you are having two plus I group, so basically then we need to compare the strength of plus I groups. So C, CS3, 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 CH, CS3, CS3, and then CH2, CS3, and then CS3. This carbon, this carbon, this carbon, this carbon. You can see the degree of the carbon. This is a carbon which is 3 degree because it has connected with 3 other carbons. This is a carbon which is 2 degree. This is a carbon which is 1 degree, and methyl is also considered as 1 degree. So the case where the degree of carbon is more, that is having more donating nature. Like all will be having plus I. There is no doubt. All will be having plus I. Why? Because the carbon is sp3, right? And I told you sp3 carbon are having plus I. So the one which is having more degree of carbon is more plus I in nature, right? Is having more plus I effect. Got it? Okay. And then suppose,
Sir, could you explain why it's 3 degree and 2 degree?
this carbon is attached with 3 other carbon.
So the
Like-
last case, sir, the last case. Minus
This
CH. That one.
Actually, this one is not attached with any carbon. So it should be 0 degree, but there is no term like zero degree. Okay. That is why we called it 1 degree only.
Okay, sir.
Yes. Then CH2, CH3, that is 1 degree and 2 degree. But how to compare between these, sir? Actually, you can see both are 1 degree, But normally you can see that there are more plus I groups here and there is less plus I group here. So it is having more plus I effect. Got it?
Yes, sir.
CH2 minus, NH minus, O minus. So this is the case. These are the group which are having plus I only. I told in the last class that negative charged ions are having plus I. So which is having more plus I? C negative. Why? Because beta you can see left to right we are going. So electronegativity is increasing. And when the electronegativity increases, donating nature, electron donating nature decreases. Electron donating power we can say that decreases. Electron donating power decreases. So plus I effect also decreases. But I tell you one thing, like the atom which is more electronegative now, more electronegative are known for keeping the electrons. More electronegative atoms are known for having the electrons close to them, near to them. They will keep the electrons near to them. Okay, they will not donate the electron. So when the electronegativity increases, atom wants to keep the electron, not to donate the electron. Okay, so which is less electronegative? Carbon. So carbon will be having more donating nature. Got it?
Okay, sir.
Yes, sir.
So what was this? This was strength of plus I group. Strength of plus I group. In the similar way, we can see strength of minus I groups. So minus I group actually we have seen three categories which are having minus I. No, we have seen three categories. One which was positively charged ions, one which was neutral, and one which was having partial positive charge ion. So you tell me one thing here. If we are having three category, complete positive charge, partial positive charge, and neutral, then which one should be more withdrawing in nature? Which one should be more withdrawing in nature? Which is having complete positive charge, right? The atom which is having more positive will be more withdrawing than partial positive charge, and then we can say the neutral one, right? Got it?
Okay, sir.
So this will be the order: complete positive charge, and partial positive charge, and then the neutral one. Okay, so from here we can tell like this: NH3 plus NO2 NH3 plus NO2 and then NH2. So beta, like from here you can see this is the one which is having complete positive charge, so highest minus I. Then this is the one which is having even partial positive charge, it is having, right? It is having partial positive charge. And then NH2 which is neutral, it is not having positive charge, right? So from here we can say this will be the order of minus I effect. Now you tell me one thing. Suppose we are having three group which are having partial positive: NO2, C triple bond N, and then CHO. Which is having more minus I? Which is having more minus I? So like all the group, if they are having if all the group are having partial positive charge only, because this is having partial positive charge, this is partial positive charge, this is partial positive charge, then you can directly compare by the electronegativity, right? Because that is the only difference. So nitrogen is more electronegative than carbons. But these carbons, how to compare in them? Because this is sp carbon, this is sp2 carbon, and I told you sp carbon is more electronegative than sp2 carbon. So this will be the order of minus I. Tell me, got it?
Okay, sir.
So what is the order here? You tell me. What will be the order here? And what will be the order here? Order of minus I effect.
So fluorine is most minus I.
Yes. Yes, yes. Fluorine is more minus I, then OH, then NH.
So one is
Because
decreasing order.
Decreasing order, right? Because the En is decreasing, so withdrawing power is decreasing.
Second one, CL, FBRI.
Why are CLF? Why CLF are good?
So electronegativity, no?
Electronegativity decreases down the group, yeah.
Okay, sorry. Yes. FCLBR. I thought electron affinity, sir.
You are telling electron affinity. It seems that you are just repeating the thing which is there in your brain. You have to see the concept also, no? Minus I, they are asking. Okay, then what about this? Compare in this one also. What will be the order of minus I? A, B, C.
ABC itself.
ABC only?
Yes, sir.
Yes. And Anirudh, what is your answer?
Yes, sir. ABC.
Yes, this is the case where student makes the mistake. Actually, they see fluorine and they find them it is more electronegative, so it should be more. But better see here, no, this is the thing. Complete positive charge, partial positive charge, and neutral. So which is having partial positive charge? This one. Nitrogen is having partial positive charge, no? Polar pi bond wala case. It is the case of polar pi bond. This one. Partial positive charge. Partial positive charge comes when polar pi bonds are there. So in NO2, there is a polar pi bond. So it is partial positive. And these are neutral ones. So neutral one will be less withdrawing. Na? B. Then A and C are neutral. So A and then C. This
Okay, sir.
Got it?
Yes, sir.
Okay, so now let me write some questions for you to compare the stability. Okay, you have to tell me the order for both.
So for the first one, order is C, A, B, D.
In first one, the order is
C, A, B, D, sir.
C, A. Very good. And Anirudh, your answer is also same?
Yes, sir.
Very good. Okay, second one.
Sir, D. First one.
There
D,
is a
B.
positive charge. Positive
Oh,
charge is there this time.
okay, sir.
Sir, BDCA.
BDCA, no.
So could you do this?
So in the first one, there is a CS3 group, which is plus I. Carbobutane will get stabilized by plus I. Fluorine is minus I. This is minus I, and this is minus I. So A should be the highest one there. A should be the most stable one. B, C, D, there is a minus I group. And minus I, more is the minus I. More is the instability. So D will be least. And then it will be B. And then it will be C. This will be the order. Yeah. Understood?
Okay, sir.
Okay. Two more questions we will be doing for the stability comparison. Like this we are comparing now. This we are comparing only on the basis of inductive effect. Okay, we are not involving resonance and hyperconjugation now. But for the question, like question you will be seeing, that will be having even resonance effect also. Like NO2 you have seen it is having minus I. But along with this, NO2 has minus R also. So this will also cause this will also impact the stability of intermediate, right? Collectively we have to see the stability then. So but only we have done inductive, so now we are seeing on the basis of inductive. When we will do resonance and hyperconjugation, then we will see the combined effect of the groups, right?
Yes, sir.
Okay, try this one here.
So what is D, sir?
What is D? Deuterium, isotope of hydrogen.
Okay, sir.
And I'm telling you one thing here, that if you see the plus I na, so CS3 has plus I. In the same way, CD3 also has plus I. CT3 also has plus I. But which is having more? CT3. That is having more. Okay, like heavier isotope is having more plus I. Tritium is heavier. Deuterium is heavier than hydrogen. You know the mass number? Mass number of hydrogen is 1.
One.
Deuterium is 2. Tritium is 3. So more is the atomic mass, more will be the plus I. Okay, try.
The most stable is B, sir.
Check again.
Sir, C.
Beta C will be there, na, Varun. It is isopropyl group. It is having 2 degree. The degree of carbon is 2 degree. So this is having more plus I.
Okay, sir.
C. Then
So CBAD.
and Varun, what do you say?
Yes, sir. CBAD.
Very good. Next.
Sir, only chlorine will be minus I here, or chlorine will be plus I, sir?
Chlorine is minus I. Na?
Okay, sir.
Halogens are minus I.
Sir, C.
Hmm.
Then
C highest. Check again. Think.
Sir, if there are two neutral atoms, then how do you check which has more stability, sir? The order, sir.
What two neutral atoms here? What are two neutral atoms?
One, sir, chlor. Oh, nothing. Okay, 1 second, sir. Sir, ACBD.
ACBD. No, actually, see, this is a negative charge ion. Negative charge ion is destabilized by plus I, right? So let us just write the effect of these. This is having plus I, this is minus I, this is plus I, negative charge ion, and that is minus I. So it will be B and D are more stable, right? And among B and D, B is the case of partial positive. So B is more. Then there is D, right? And then between A and C, both are plus I. Now, how to compare the plus I? Now, you tell me one thing here. CS3 is the carbon which is CS3 carbon which is having plus I. O negative is also plus I. But negative charge ion will donate even more electrons because that is a negative charge. That is having more electron density. That is having extra
no,
electron. So it will donate electron density more always, right?
no.
So the atom which is negative charge will donate the electron density more. That is why in the case of C, it will be more donating. So when it is more donating, that means it is destabilized. So C is more destabilized, then it will be A. This is the order. Got
So
it?
more plus I means more stable, no, sir.
Beta minus charge, na? That is the minus charge. Minus charge is stabilized by minus I. But that is plus I. So minus charge becomes stable when minus I group is there. But when plus I is there, it is donating the electron. So it is destabilizing the anion. No?
Okay, sir.
Varun,
Okay, sir.
Anirudh,
Yes, sir.
got it, no?
Yes, sir. Got
Yes,
it.
sir.
So this was all about the inductive effect. Any question of inductive you can do now. But like this effect is a very smaller effect. Inductive effect is a permanent effect. All these effects, inductive, resonance, and hyperconjugation, are permanent effect. Okay. But the thing is, inductive effect is like very smaller in comparison to inductive and hyperconjugation.
Okay,
Okay,
sir.
inductive is just like bike, and resonance is just like aeroplane, and hyperconjugation is just like a car, sports car. Okay, but
Okay.
which run fastest? Aeroplane, right? And then car, and then bike, we can say. So basically, inductive is very smaller effect. It has less impact on the stability. Resonance effect has a large, huge impact on the stability. Hyperconjugation is having the impact in between of these both, actually lesser than resonance and more than inductive. That is the order. So next class we will see the resonance here.
Okay,
Okay,
sir.
Okay, sir.
what do you say? Now, are you able to understand whatever was taught in the class?
Yes, sir.
You will be able to do the question now.
Okay, sir.
Okay, so in the resonance, you know how to draw the resonating structure.